Hi everyone, and welcome to this tutorial introducing Bifrost. Bifrost is a visual scripting environment for Maya. It's very similar to Grasshopper found in Rhino 3D. And with Bifrost, you can do all sorts of interesting things. You can scatter geometry, which is going to be the subject of this tutorial. It's going to help us introduce the interface. And you can also work with volumes. You can erode geometry with fields. You can do all sorts of great stuff. So let's just dive into it and create the little setup that I'm showing here. Okay, to get started, we need to open Bifrost. You can find Bifrost under Windows, and you should see the Bifrost Graph Editor option here. If not, you simply need to go to Settings, Preferences, Plugin Manager, and search for Bifrost. And make sure that you hit Load and Auto Load for all of the features, refresh, and close. And now we should have the Bifrost Graph Editor, which we can open. And what I like to do is, let me shrink that a little bit. I like to take the Graph Editor and you can park it underneath the other tabs here on the right. And then it becomes very easy to toggle it on and off. Okay, so Bifrost works very similar to Grasshopper for Rhino. There are some examples that you can get started with in the Bifrost browser. I recommend looking at some of the scatter pack examples. Scatter and volume is cool, scatter on points. These are great places to start. But today we're going to be building something from scratch. So let's create a graph, and then I can use, it's pretty intuitive to get around on the graph, scroll wheel for zooming in and out, middle mouse button for panning around. And you can also use F for framing different components, which in Bifrost are called compounds. And just like Grasshopper, we can grab objects from our modeling space and work with them in the graph space. So let's get started by what do we want to do? We want to create some geometry and scatter little primitives on top of that geometry. So let's start by creating the things that we're going to scatter. So here in the poly modeling, I'm going to go ahead and create a platonic solid. This is, let's look at the attribute editor quickly. A little look at the shape node, tessellation attributes. Oh, nope, the creation node here. Okay, great. So I'm going to get rid of these subdivisions and make sure that spherical inflation is off. And I have this little isosahedron, so that works. And so this is going to be the first thing I'll scatter. And then let's create another one, a second one. And I'll do that again here. Create another one. I'm going to change him to a dodecahedron, get rid of the subdivisions, and make sure that spherical inflation is off. So now I have my two primitives that I want to scatter. And so if I want to get those into Bifrost, all I need to do is middle mouse button drag. So middle mouse button drag. I'm pressing down on the middle mouse button, which is the scroll wheel, and dragging these things over into the Bifrost graph. So these will be the shapes that I scatter. Those will be part of my series of inputs, so I can delete that input. And then output, I'm going to start dragging over here because we're not going to need that little compound for a while. And I'll just move these guys over. And then we need geometry to scatter these items onto. And so let's make another platonic solid here. And what do we want this one to be? We'll make this one a dodecahedron. We'll actually add some subdivisions to this one, like that. And maybe let's take the radius up to 14. So we want that to be much bigger. So I'm just going to frame that in the scene. And we don't actually need to see the other two for now. Well, actually, let's just keep them on. And let's just take this one and move them over. And in the modeling toolkit, I will just give it a little bit of smoothing. And now I will center the pivot, delete the history, and freeze transformations on this object. And now this is what we have in our scene. So we have a bigger platonic solid with a little smoothing, and then these two other guys that we're going to scatter on top of this bigger one. So obviously this bigger one needs to come into the graph. So, so let's call this large solid. I'll change its name, then bring it over. So we have our large solid shape, and that is going to be the first thing that we are going to work with. So the large solid shape, let's go ahead and deselect it in the modeling viewport. And also, let me just make sure I'm zooming in here so you can see everything that I'm doing. We want to first start to scatter some points on this. So how do we add things? How do we add compounds to the workspace here? Well, you hit the Tab key on your keyboard. So hit Tab, and then you can search for components. So we want to scatter, and what we want to use here is scatter points. Scatter points will scatter points on an object, and what I need to do here is drag the mesh, the large solid shape, over into the geometry for scatter by number. So just left mouse button, drag that over, and I don't see anything. However, I can visualize it using the point scope. So point scope. So again, I'm always hitting, when I'm getting these components, I'm always hitting Tab and then searching for them. So point scope, with the point scope, and now I can drag this over. And then you'll see here that many of the compounds in Bifrost allow you to preview. And I can use that here. And it's very difficult to see, but there are these little points appearing on my large geometry. And generally with visualizing things in Bifrost, you can either use the display, toggle on the display on compounds if they're available, or the other really core component you'll be using all the time is terminal. And terminal allows you to also display items that don't have a built-in display feature. And then of course you can use the output, and output is ultimately how you save or bake geometry back into the Maya modeling space. So the point scope is a quick way for us to visualize these points on the object. And let me just toggle this guy off by hitting Control H. And now I can see my points here. And on the point scope, I can also make these a little bit bigger here. I could make them spheres and give those spheres a radius as well. So this becomes a very quick way to visualize the distribution of points on our object. Okay, we are going to just leave this as it is for now. And now what do we want to do next? Let's scatter our objects. So I'm going to go ahead and hit the Tab key, and I will choose, let's see, what do I want to choose here? The component or compound is called instances, set instances. So set instance geometry. So we'll select that. And then let's grab our points here. And then we have our shapes here. And so these are going to be our instances. And I'm going to just start with one. And so I'll grab this instance geometry and pull it over. And we don't see it by default. And this is where the terminal comes in. So we can grab this terminal. And again, if you need to make one, hit Tab, type terminal. You'll be making terminals all the time when working with Bifrost. So I'm going to grab the instances here, put them into, let's choose proxy. And as long as proxy is displaying here, we should see our objects. Now, let's see, two-sided lighting, no. Why they are black, I'm not sure. But let's just go ahead and keep rolling with this and see if baking these instances helps. So what we can do here is we have the instances, and let's hit Tab and get a Bake Instance Geometry tab. So the Bake Instance Geometry tab will allow us to turn these into meshes. And let's grab instances, put them in here, and now let's put our meshes in the instances area here. And let's see here, display, proxy, okay. And I'm going to try to see why these are black. So let me pause the video while I figure that out. Okay, so to fix this, I can simply grab these objects, and I'm not sure why our standard surface is rendering black, but we can just switch this to assign favorite material Lambert. And now we can see our scattered primitives. So if your Bifrost objects are black. Also, another thing that can happen if you don't see your Bifrost objects, you can actually, if you hit Control H, you can hide the Bifrost graph. So sometimes you toggle it off and forget to turn it back on. So Shift H will toggle it back on. So now I can see my objects, and I can see that this is working. And then if I want to complete this step, so let's see here. So I've got this into the output now. Let me delete that. So I can toggle on and off the preview of the instances here. And then if I want to bake a copy of this into the Maya modeling space, I can grab the meshes out of the instance. So again, it has to be the, let me make this bigger, sorry, baked instance geometry. I need to pull this over to merged meshes. And then I can right click on the merged meshes output here in the output compound, and I can find the option create Maya mesh. And now I can select those merged meshes and hit, let's see, hit the W key on the keyboard. Oops. So the merged meshes, and they're, let's see. Yeah, so basically the pivot point is over by the origin, so I can just center that pivot. And now I have this mesh. Now this mesh is going to be by default still linked. You can see it looks a little bit different, and that's because there's smoothing on the normals. So if I go to mesh display, harden edge, it will look the same. And then I should note also that this is linked by default to the Bifrost geometry. And so if I go, for example, back into the scatter by number and start reducing the number of scattered objects, this is going to be updating over here. So if you don't want that to happen, then you can either make another duplicate of this, so Control D, and then move that duplicate and save that as a copy, and then continue editing this. Or if you just want to break the live link on this one, you simply need to come up here, and I just like running all three of these at once, center the pivot, delete the history, and freeze the transformations. And now you'll see when we come back over into Bifrost and start changing this is no longer updating. So now this is baked as one mesh, and obviously we have a lot of little meshes inside this one mesh, and if we wanted to further edit and delete these, we could go into the modeling toolkit and we could separate this mesh. Of course, that's going to give us a ton of little meshes, so I don't want to do that. So I'm just going to go ahead and delete this one. But that's how you bake things from Bifrost into the modeling viewport. All right, so step 2, now that we've scattered this, we need to do a couple of things. Let's go ahead and we want to get our second instance in here. And to do that, so when we plugged in our, so let's put in our second shape, just make sure that you have instance geometries unfurled here, because if I plug this one in, it's just going to be hard to see, but if I zoom in here, oh, well, that's fine too, because now I have them both linked up. So you can, if this is not unfurled, then you can just bring the second one into instance geometry. If you want to get rid of it, I can just select the wire and hit delete on my keyboard. And then if you wanted to replace the one that we have there now, we could go ahead and go to, we could just swap it out under mesh. But for that, you have to have this open. So you can see that now I can toggle between these two different meshes. Oops, undo that, delete these things. But yeah, you can pull the first one in, put that in there. And then if we want to replace it, we simply drag that into mesh. And if we want to add one, then we add it into instance geometries. But you can see here that when I have two plugged in, only the first one is showing. So we need to use another compound, and that compound is called, grab it here, randomize selection by probabilities. Catchy title. So tab, randomize. So if we type randomize underscore selection, randomize selection by probabilities, we can grab that. And now we can grab points and plug our points. And so this is interesting to note that all of this information gets saved on the point. And you're not actually working with the primitives, you're typically working with the points and then updating the metadata on the points or the properties of the points, and then that gets pushed out to the instance geometry. So now we're going to grab our randomized selection by probabilities, and we look over here and what we're seeing. The first one will have a probability of 2, and then the second one will have a probability of 1. So let's just go ahead and complete this out points here, and now you can see that I'm getting both shapes. So some of these are the icosahedron and some of these are the dodecahedron. That's great. And we have more than one kind than another. If we want to make them equal, then we need to, over here in the probabilities tab, give them both a probability of 1. If we want 1 to be twice as likely, then we can hit it to 2, or we can make it 3 times as likely, or 5 times as likely, and then you've got a lot of 1 and just a few of the other type. For now, I'm just going to keep the ratio at 1. And so now we have 2 types of objects scattered on our primitive. So far so good. We could bake this out. But I think the next thing we would want to do is start randomizing the other properties. So let me just, maybe it's easier to see here. No, I think it's easy enough to see that. Okay, so this is, I think, important. Set instance geometry, bake instance geometry. So what we see here is that all of these little objects, like they're in slightly different orientations, and that's because they're responding to the surface normal of the basic object. And this might be easier to see if I use something that had more of a clear axis. So why don't I go ahead and just drop in a little cylinder here. Let's scale that down and scale it up. Scale it up a little bit. And let's replace, for now, our primitives that are scattered with this one. So let's drag over that cylinder shape. And now let's just get rid of these instances by hitting delete. And now I'm going to bring that one into the instancer. And okay, cool. So if I turn on our large solid just in the modeling viewport, we can see that we have all of these guys scattered all over, and that the orientation of the object is being scattered based on the normal of the base object. So, so they don't have exactly different rotations from one another, and they definitely don't have different scales. But the orientation is different just based on the surface normal. And let's just go ahead and start adding some variety to this. And where would we want to do that? First, let's maybe adjust the scale. Added some things here, which I don't want. Let me get rid of those. Let's adjust the scale of these objects, and we can do that. And I'll just keep the cylinder on for now, and then I'll bring back the other objects in a little bit. Okay, so how would we want to adjust the scale? Where would we adjust the scale? We can do that after the scatter because that gets saved on the points. And I'm going to use the randomize, let's see, scale, randomize point scale. And now I can grab the points. I can grab the out points. And then with the randomization here, I want to unfurl this because I'm going to want to give this both a min and a max. And let's go ahead and do that now. And we do that with a value. So tab, and I'm going to hit value, type value, find a value. And this just allows us to get different kinds of data that we can push into our compounds. In this case, our value is going to be a number. It's going to be a floating point number, which should be fine. But if we needed to change this to an integer, which is sometimes called a long here, or a vector, we could just click this here and change it. But we don't want to do that now. What I'm going to do is Control-C, Control-V. I'm going to make 2. And let's say our minimum size is going to be 0.25. And then our maximum size will be 0.5, or let's make it actually something bigger, 2. And let's plug our minimum in here and our maximum in here, maximum there. And so that's great. And now we simply need to make sure that we are connecting this point scale here into points. Okay, great. And now we can see that we have little ones, big ones, and some things in between. So now we could scale this down, take our maximum value, maybe take our minimum value and scale that up. So now we have variety here. And let's say I'm happy with the distribution, but I would like to globally change all of the scale. It could be nice to, let me just make a little room here in the graph. Let's see here, grab that. I think it would be good to scale the points again, to have another value to scale the points with. So I'm going to hit tab and start typing scale, and I can hit scale points. And I'll put another scale points, another scaling compound in here. So scale points, and make sure you can see that, out points, and we need to bring that over here to this, to the randomized selection by probabilities. Okay, and let's copy one of these values, Control-C, Control-V, and plug that into the scale feature here. So they get small, but of course I could now bring them up and down. And when you see this little slider up here, you just need to hit the left mouse button and you can slide and drag, or you can obviously put in a value that you want. Okay, so now we have these things scaling nicely, so that's cool. And let's change their, now let's introduce rotation. Okay, so make a little more room here in the graph. So we've been able to set up our instances. At the end, we will be able to grab these guys and bring them along. We'll put these back into the instancer eventually. So I'm just going to move that over there. But for now, let's just keep working with the cylinder. And so now that we've scaled the objects, let's rotate them. We'll do that here with randomize again. So we're going to randomize the point rotation. Randomize point rotation. Now we can grab our points, and we can grab our out points here. Okay, and then what we can see here is that we have in radians, and I think we're stuck with radians here. I don't think that we can actually change this to degrees, but we can set this with radians. And so what we're seeing here is that 3.14, that's pi. And so we're going between negative pi, or negative, this is basically an angular or degree dimension of, in degrees this would be like 360, right? So we're going from negative 360 to 360, and here we have very little rotation in x. So this is x, y, and z. So we have very little rotation in x, very little rotation in z, and a lot of rotation in y, which we can't actually see here because we're using the cylinder. So it's just spinning around the vertical axis here. But if we then start copying and pasting this value into these other spots. Oops, this one wants to be positive. So if we get that full range of rotation in X, now we can see that these things are rotating in X. And then here, we can do that. Copy and paste this one into Z. And now we've got that full range of rotation in Z. So the objects are completely scattered around and rotated. And then of course we could change the seed here, local space versus the world space and the local space of the object. Rotate existing values. They don't have any additional existing rotation on them. And then you can change the order in which these things happen. So you can play around with all of this, but this is how you can rotate the objects. All right, so now we have all of we can see that all of these objects are rotating. We've got the scale linked up. And let me bring this back to multiple instances. So I'm going to get rid of the cylinder. I'm going to get rid, and now I'm going to plug these instances back in, like this. And this. Oops, sorry, instance geometry. We want that one there. And then we pull this one up into instances, and now we have these things scattered around. So this is looking pretty good. Now, maybe, let's see, let's add many more instances now. Randomize point scale, scatter by number. So we have 430 here. If we take this up to maybe like 1,000, we're getting much more coverage on the object. Or if we take this up to 2,000, oops, not 200, but maybe 2,000. We're completely covering the object. And now let's come back to our point scale. So let's scale our points here. So zoom in on this, and now we could scale this down. So this is our global scale. And I don't know why that thing is selected. So we can see that we have a bunch of objects on this. Let me just go ahead and maybe turn off here the wireframe on this so that we have a lot of objects here. Okay, so we've got this scattering over, and let's maybe even turn our large solid off, and maybe we'll turn that wireframe back on like that. Okay, so we have a ton of objects scattered on this. And what I want to show you in the next step to this script is how we could thin this out by using fields. So perhaps we want only part of our object covered with the instances. And we can do that by here in the randomized point scale, there's a little input for weights. And if we give some weight value to that input, then we can change the distribution. So the way that I like to do this is with a fractal noise field. And sorry, it's not in randomized point scale that we want to do that. We want to do that in scatter by number. And we're going to use density weights. Sorry about that. Density weights and scatter by number. Okay, so coming back to the very beginning of our script, we are going to use a fractal noise field. So fractal noise field, grab that. And this is going to allow us to basically put, you could think of it as a texture, an algorithmically generated texture on our object. And where that texture has lighter or brighter values, we'll scatter the objects, and where it has darker values, we won't. So we can just plug this in and see it working, but maybe we would also want to actually see how this texture is going to be distributed on our object. And we can do that with a diagnostic material. So I'm going to hit Tab, and then I will type assign, and then we can see assign diagnostic material here. Great. And we can now bring our mesh into the diagnostic material, and then our fractal noise field will be the emission color. So we can grab the noise field output and put it in emission color. And let's go ahead and let's have a point scope. I'm going to turn that off. And then what do we have visualizing over here? We have the output. So I'm going to delete the connection to the output right now. That means that we are only seeing the instances in this terminal. And you could make a new terminal. Maybe it's easier since that's all over there, but let's do it this way. Let's grab our terminal and I'm going to bring them all. You can have multiple terminals, which is totally fine. I'm going to drag this terminal over, and I'm going to grab the diagnostic material here, and let's put this in the diagnostic tab here. And that way, on my proxy, I can actually come over and see how that diagnostic material is being assigned. So let's bring that terminal all the way back over to the end, since it's our final one of our final outputs here, and we can see how this is being assigned here. Now, I'm wondering, so we can see the way that this noise field is being distributed on the object. I might, for visualizing this, want to add more divisions to this guy. So if I go to, I could do that in the modeling toolkit, or let's just go to mesh. And if we hit smooth, let's try that. Oh, that's our Bifrost graph. Let's go to the large solid. So the large solid, that's what's being previewed here. Go to mesh and let's smooth it. And let's add more divisions, maybe like 3. Yeah, I think that's good actually. So 2 might have been fine as well, but let's go ahead and turn off here. There we go. Turn off the wireframe. And now we can see exactly how that noise field is being distributed on my object. And so we might, because it's so dense, not notice a huge difference at first for how our instances are being scattered. So let's come back to our noise field and see if we can. Let's see if we reduce the number of frequency. 3, that's fine. Let's change the frequency itself. So if we make the frequency lower, like something, let's try like 0.1. Now you can see that we have this much bigger shape here. If we change the number of frequencies, then it gets sharper. So if we, obviously we need 1, but if we give this 1 frequency, then you can see that we have much clearer shapes here. And then if we give this a frequency of say like 2, something like that, they get a little bit more elaborate. And if we go up to say like 5, you see that they're much noisier. We get more detail in this texture. So I'm just going to leave this at 3 for now. And depending on the scale of your objects, that might be more or less important. But we should see very clearly where things are going to be scattering and not scattering now. Okay, so let's turn on, zooming back here, back to our output. Let's turn on also our proxy. Obviously these things are not, so we had the instances in the proxy, and we have the diagnostic material in this diagnostic tab. So we can view both of them at the same time. And let's go back and now link up our fractal noise field to the density weights of scatter by number. So put that in there. Okay, cool. Now you can see that we're getting scattering where where it's brighter, and we're not getting any where it's darker, but we're also not getting a lot in these gray zones. And so we need to play with something here. So we could play with our fractal noise field. We could, frequency is not going to do it. Frequency ratio is not going to do it. The ratio is not going to do it. The number of frequencies, not really going to do it. The magnitude, okay, the magnitude seems to help. So that's one way we could do it. We could raise the magnitude, and that makes those white areas brighter, and we tend to get more objects. The other thing we could do is just simply leave this magnitude at 1. We could go back to our scatter by number and change this now to a really high number. So something maybe like, yeah, instead of 2,000, we've got like 20,000. But we're not actually going to have 20,000. I don't think so anyway, because that's maybe the maximum number, but then some of them are getting filtered out based on where this scattering is happening. Okay, so let's go ahead and let's see where our objects are being scattered here. Let's bring this over and turn on. Right, so now we have that. We can see where those things are being scattered. And now we could play with our fractal noise field. We could change the number of frequencies. That's going to filter things a little bit. We could change the frequency itself. So if we wanted, let's say, so if the frequency is lower, we're getting like lots of big patches. And then if the frequency is higher, we're getting many more patches. And maybe this is where we would actually now need to, in our scale points, bring that scale down like that, so that we're capturing all of that detail. We're seeing how that detail is showing up in the geometry. And then we could go back and always play with our scatter by number and add more geometry to this if we want. Yeah, so now you can see we have like super dense amount of geometry. I think I raised this up to 200,000. So we have lots of geometry, and then that's going to help us capture all of the spots where the noise field is being kept on this. Okay, so I think that is a really good overview to how this is working. And maybe what I could conclude with is just reminding you how you would get this back into the Maya viewport. So I'm going to turn off all of the things in the terminal here. I'm going to take these merged meshes back into the output tab. And then in the output tab here, I can right click this and create Maya mesh. And then going into the channel box, I'm going to go ahead and grab this merged meshes node W, bring that over, and then delete the history, freeze the pivot, or center the pivot, and all that jazz. And then I think it's good practice under mesh display to harden the edge, and then these things should display properly. One thing I should also point out is just delete that. It's very easy. So I have a plane that's hidden here, Shift H. So there's a plane. So I have this plane, and let's look at how quickly we can just rearray this onto a plane. And under Bifrost, got this whole setup. So now let's say we want to test a different geometry. I could come back to our large solid shape, and I can plug that into, I can plug a new shape into these things. So let's look at a useful compound, which is called pass. And pass allows me to basically just, it makes it sometimes easier to switch. So for example, if I wanted to switch a new shape into the position that I've been working with this large shape, I'm going to have to reconnect all of these wires. So what I might want to do is go ahead and put that, basically put everything into this pass, and then the pass could be the thing that then gets linked up to, its output gets linked up into these multiple places. That way it becomes very easy for me to switch. So I want to grab this plane, so I'll grab it over here in the outliner, middle mouse button, drag it over. Now I have the plane shape, and now I can very quickly put that into the pass. And now we can see here, and maybe just hide the shape, Control H. We can see here that we are scattering these on top of this. And then, of course, we could go back to the fractal noise field, and we could start changing these items. This is also where you would probably want to start putting values. So if I make a value, right? And you can even create value nodes. That's actually something that's useful to know. But let's say we like this magnitude 1, or frequencies. Like this frequency, we can right click here and we can create a value node. And it's just going to go ahead and create the proper kind of value node for that object. And then Control C, Control V, I could just copy it. And with this frequency, I could put that in here, and now I could start changing that frequency value. Actually, was that where it was? Number of frequencies. Yep, that's fine. Number of frequencies here, 3. We're not actually seeing a big change here. When I take it down. But for some of these things, like frequency itself, so let me delete that and change the frequency. So create a value node for frequency. And then we should, yeah, with the frequency, we see a much bigger change here. So what I encourage you to do is Control-C, Control-V, like create these different value nodes and hunt for cool settings. And then once you have, why is that not changing? That's very strange. Because it was the frequency here. So frequency should be the value output. Frequency, plug that one in. And if we start changing this, yeah, so that's updating. And this one should be different. Yep, okay, so now they're linked up. Not sure, that seemed to not be working before, but it's definitely working now. So I kind of big shapes and then small shapes, and I could begin exporting these and combining them in interesting ways. All right, so this concludes our introduction to Bifrost. I'll do some future tutorials covering other aspects of it, and hope you enjoyed this.